Hey everyone, this is Bhargav Sudhar, and today we will discuss another very important algorithm. So that is Kruskal's algorithm. Okay, so in this session we will discuss how to find a minimum spanning tree using Kruskal's algorithm. Now in previous session we already discussed how to find a MST, so that is minimum spanning tree using Prim's algorithm. So just let us discuss the second algorithm. Okay, so let us jump to the example. So before proceeding the example, let us recall what is a minimum spanning tree. So first of all, let us discuss what is a tree. So it is a acyclic graph. So a graph which does not contain a cycle, that is a tree. Fine. Now what is a spanning tree? So what is a spanning tree? So first it has to be a tree. Fine. Then spanning tree. So a spanning tree, that means it should contain all the vertices of the given graph. Fine. And then all the vertices are connected via an edge, and it should be a acyclic graph. Okay, so that is a spanning tree. Now what is a minimum spanning tree? So it should be a spanning tree first, and what does that mean by this minimum? So that means that that tree should contain a minimum weight, a tree of minimum weight. So that is a minimum spanning tree. Fine. Now in previous session we already discussed how to find a minimum spanning tree using Prim's algorithm. So now we will discuss the same example using this Kruskal's algorithm. Okay, so you can get the idea that which method you should prefer. Fine. So the question is, determine minimum spanning tree for the given graph using Kruskal's algorithm. So this is the graph. Okay, so this is the same graph that we've discussed in Prim's algorithm. Okay, so here, see what we'll do here. In Prim's algorithm, we selected the vertices. Okay, so in here we will select the edges of the minimum weights. So first what we will do here, we will arrange all the edges in increasing order. Okay, that means the weights. Fine, according to the weights. So what is the edge which has the minimum weight? So as you can see that this is AF, so that has weight 1. Now then this A and D, so that has weight 2. Then next 3, so that means this FE, so that has weight 3. Then ED, so that has weight 4. Then this DC or CD, that has weight 5. Then 5. Then after 5 we have this AE, so that is 6. Then we have the 7, so that is DB or BD. Then next 8, so that is BC. And 9 we have FB, so that has weight 9. And last we have this E and C, so that is 10. Okay, so we have listed out all the edges having this weights in increasing order. Okay, fine. So next what we'll do, just so the same steps. We will take all the vertices, because see it is the minimum spanning tree, so it should contain all the vertices. So we have just drawn all these vertices. Fine. So now first step. So instead of this selecting this in Prim's algorithm, instead of selecting the first vertex, now here what we'll do, we'll select the edge, so that has this minimum weight. So here one by one. Okay, so here we have AF, that has the minimum weight, so that is, just take this AF. Okay, so the first step, that is AF. So in Prim's algorithm the step was like this. Now in Prim's algorithm we need to take this adjacent vertices, that is of having minimum weight, so that is which are adjacent to F and A. Here no need to worry about all this. Now second, what is this second minimum edge? So that is AD, so just take this AD. Fine. Now then third step. Now what is this FE? Then third edge, minimum edge, FE, so that is 3, so just take that edge 3. Then fourth, ED. Okay, so we have ED. Now see, if we take this ED, so this graph will become, or this graph will contain a cycle, but that is not possible in this minimum spanning tree. So we cannot take this ED. 4. Fine. Just jump to the next edge, so that is DC. So we have DC, that is 5, so take 5. Okay, then what is this edge? AE. Now if we take AE, so see, as you can see that this, if we take this AE, so it will again contain a cycle, but it is not possible as we are looking for a minimum spanning and tree, so acyclic graph. So this AE cannot be there. Then next BD. Now this BD, so we can draw this BD. Fine. So this is BD. Now see, as you can see that we have covered all the vertices and which are connected, and this is the minimum spanning tree. But see, we already we are left with this three edges. So what will happen if we take this all these three edges? The answer is this. Okay, it is the minimum spanning tree, but by the steps of this Kruskal's algorithm, these three edges are left. Okay, so let us take, see, if we take this BC equals to 8, so where is BC? This BC. So that means it will contain a cycle, so this is not possible. Now if we take FB, this F and B, so if we take this FB, so it is possible, but it is not, it won't be a minimum spanning tree. Okay, so this FB need not be there for minimum spanning tree. It is a spanning tree, but not a minimum spanning tree. Now if we take EC, so if we take this EC, then again it will be a spanning tree, but not the minimum. So there is no need to do that. So what we'll check, it should contain all the vertices and all they are connected. Fine. So this is the minimum spanning tree, and let us count the weight of this spanning tree. So what is that weight? So that means 1, 3, 2, 5 and 7 equals to 18. Now see, if you remember the last or previous session of Prim's algorithm, this answer was same and the graph was also same. Fine. But in all the cases it won't be same. Fine. So it is possible, or it may possible, that in Prim's algorithm whatever the spanning tree we have got, it can be different in same example by using this Kruskal's algorithm. So no need to worry. Okay, and yeah, again this second question. So again, if we have this two edges having same weight, so what will be what we can take? So if we have two edges or three edges of having same weight, fine. So in that case you can take any edge you want. Fine. So the answers will be according to that. So this is how you can find a minimum spanning tree using this Kruskal's algorithm. Thank you.